in class today. Let me clarify a few things for you. First, I mentioned that whenever you see a rate like 9 cubic feet per minute, it is understood to be a derivative. And in this case, based on the unit cubic feet per minute, we can conclude that this derivative is dV dt, the rate of change of volume with respect to t. And when you look at what we are looking for in this particular example, it is once again a rate, how fast the water level is rising. And the water level, based on the diagram on the right side, is denoted by this variable y. Therefore, we are looking for dy dt specifically. Now, how do we relate these two derivatives, that I highlighted in red? It is by means of the chain rule. Specifically, dV dt is equal to dV dy times dy dt. An easy way to remember this equality is that if you treat the derivative like a fraction, the dy seem to cancel out, leaving you with dV dt. So symbolically, it does make sense. So now we already know that this derivative dV dt is 9, and dy dt is what we're looking for. It remains to come up with this dV dy in the middle before we can answer this question. In order to find dV dy, we'll have to make use of the volume formula of a cone. Because the water tank here is shaped like a cone, we use the volume formula V equals 1/3 pi times x squared times y. As you have seen already, y measures the height of the water, and x here, you can see in the diagram that x represents the radius. Now, in class, I mentioned that x and y are related. Obviously, when water is poured into this tank, both x and y will increase, but they are not independent of one another. So the important observation that I made in class is to make use of this blue triangle. Let me try to draw it again. A blue triangle that I extracted from the diagram. Now, why is this triangle important? We have some measurements of this triangle. For instance, we are told that the top here is 5 feet, and the height is precisely 10 feet. So if you think of the hypotenuse, let me highlight the hypotenuse here in black. Okay, if you think of the hypotenuse here like a line, we can find out the slope of this hypotenuse. By dividing the rise over, well, by dividing rise by the run in this case, 10 over 5. Okay. Now, where do the x and y comes in? Okay. Now, based on the water level, the x is this measurement. Okay. And y is this vertical measurement of the smaller triangle. So we could have calculate the slope, okay, using x and y. Once again, the rise over the run, okay. That will leave us with a relationship of x and y that is proven to be quite essential to answer this question, okay. If you isolate the variable x here, you will see that it is equal to 1/2 y, okay, based on the geometry of the triangle, okay. So using this relationship as well as the volume formula right here, okay, we will be able to modify this formula expressing the volume in terms of y exclusively. Okay. That will help us determine the derivative eventually, but before we do so, let's simplify the right-hand side a little bit. In fact, this is one place that I made a mistake, a small mistake in my calculation in class, okay? In particular, the denominator here should be 4 after you square, okay? Okay. So after a little bit of simplification, we will be able to differentiate the volume with respect to y, okay, and find out this crucial information before we can finalize the answer for this problem, okay. So now that we know now that we know dv, dy, okay, we can go back to our chain rule and come up with the answer, okay. Remember that we were looking for dy, dt, and the question mark we just came up with, okay. What was this question mark again? Okay, the question mark is given by this pi over 4 times y squared. Okay, so let me put that in. Followed by dy dt, right? Okay, so solving for dy dt, okay, will enable us to finally answer the question how fast the water level is rising. In particular, okay, remember that we are interested in, or at the moment, when the water is 6 feet deep. Okay, so I will have to replace the y by 6 feet in this case. Okay. And you will come up with the answer, I believe, 1 over pi for this derivative. Okay. I did make a small mistake in the calculation when I work out the answer here. So make sure that you see the correct answer in this example number 1. It should be 1 over pi for the derivative dy dt.